So, in this part we will see how we can start using cover. Now, we were not going to see the final version of the cover. We're going to start creating the logic, creating the different behaviors characters will have when they are in cover, and on a later part we're going to see that the cases that I've talked before, that if it's a cover that is partial cover, as you can see indicated by the indicator of course, then you can actually jump over it and your character will walk straight. But because this that is a bit of a work, since we also have to do changes to the Pathfinder, we are going to see we're going to start the basics of it, and we're going to see that on a later video. And another thing we're going to see is when I go into a partial cover, we're going to make the character actually play a different animation when he reaches that cover, and when he aims, when he is going to shoot somebody. If he shoots to somebody that is straight ahead of him, he will get up from a standing position and he will shoot. If he's not straight ahead of him and he's somewhere to the side or another direction, he's going to get out of cover. Now of course it's pretty rough right now, and as you can see it doesn't rotate, since later on we're going to actually use the IK aiming system we created for other projects, a version of it, and we're going to see it used over here. And if the character, he's trying to shoot somebody that is behind he's actually behind him, he's going to rotate and play the animation and the behavior that he has without him being into cover. Now, being in cover, not in cover right now doesn't add anything to the combat. Okay, all this stuff are for later use, and we're going to see when he's actually, let me restart it again. We're going to see, apart from how to rotate the camera, when he's on full cover and moves like that, he's actually going to play right now it plays the run animation, but he's going to play the animation that he gets out of cover and shoots exactly like XCOM does. Okay, and it's going to be pretty bare bones or pretty simple right now, because this can be tweaked a lot to fit any type of game or the type of game you want. Okay, and I think it looks pretty nice. So let's see what we're going to do. Now, on our nodes we have down here, when they are created, right now they are not created. If you remember, we had the node references. For every node had a node references node. So we're going to add a few more stuff on the node references, and that stuff will be the cover. But to actually create the cover, I'm going to create, before we see that, I'm going to create a cover indicator, which is also a prefab, although you do not have to make it a prefab. Okay, it's an empty game object that has 4 other game objects that include a sprite renderer. Right now it doesn't matter the sprite, since we update it depending on what type of cover it is. We're going to write a new script, which is cover indicator, and so let's see this. We're going to include the UI, the world UI namespace, and the namespace for the generics because we're using lists. Now, we need a list of class covers. This class is this one. And we have a few enumerations, one for direction and one for cover status. Now, direction is north, south, west, east. Okay. In most of the time, you shouldn't be care about having the correct order, but there's some other stuff that you should probably care to have at the correct order. So, cover status, is it full, is it partial, or it doesn't have any type of cover. So, with these two enums, we can create a class that we can store the sprite renderer, the icon, the direction, and the cover status. So, we create a list, a public list of cover, and it is this one, and we can start assigning stuff. Now, you should keep it the way I have it here so that we know what's happening. So, the north should always be vector3, the world vector3 forward. If you turn this to global, it will show you. So we will take the blue arrow for north. So we take the north, this sprite renderer, and assign it to the first one. We'll set the direction to north, to ni, to n, and we'll set the status, doesn't matter because, as I said, we applied. So, similarly, we're going to do the S for the south, the west, and the east. Okay, north, south, west, west, east. Now, let's go back to our combat indicator. On start, we get a reference from the singleton of the world UI manager, and for each cover we have in covers, we change the status to none, and we call the new function we're going to create, which is called update cover status, and we pass the cover and the wanted status. Let's close this. Let's close this. So basically this comes over here and it enables the icon, because if it's none, we just disable the icon. Okay, so it comes over here, and if it's full, it assigns from the world UI manager, which is this one. We've created a few references, basically a cover indicator, which we assign the cover indicator, and a sprite for the full cover icon and the partial cover icon. So we can come over here and just assign the correct icon for where we are, to basically initialize it and close the icons for the covers. And we also use two more functions that we might use. One is return covers with direction, so we pass a direction over here and it searches in our list for the same direction and it returns it. Okay, so since we have directions, and since directions are unique, and they should be unique, okay, you cannot have two indicators both facing the north. It's just useless. And even if you have two directions facing north, this one will return the first one in the list. And the other, which is public function, we will pass if we want to set the cover. Okay, we pass the direction, we pass the cover, so we return the cover position from the return cover with direction, and we update the status, and then we call the update cover status. So this is basically the only thing we're going to do in our cover indicator. And let me close this. So on our UI manager, on our world UI manager, we have the variables I talked before, and we can have also this bit of code which just takes we pass a list, and in our case a list of covers, and for each case of the list it updates the status for that list. So we basically pass the cover list and let it update whatever status they already have. Okay, because even if we do changes into this list, to actually see the update and the changes they do, we need to call set cover status. Okay, it's pretty simple. So let's move on. Now we're going to do a few changes on the grid base. Previously, if you remember, when we were creating the grid, we had over here a bit of code that read the level and it added if you have or not. Okay, if it has if there is an obstacle, or if it finds a collider, it look to see if it's an obstacle or if it's the floor and all that. Okay, let's call that level or the red of the level or level readability. We moved it though from in here, from the create grid function, and we move it to its own step after the creation of the grid. Why we do that? Because we want to update neighboring nodes if we find something inside our own node. Okay. And the other thing we actually going to add is a create cover position, which takes a list. So since every node reference now we created on our node reference, we create a simple list of covers. Okay, and we will see the other three functions we added. So I'm going to leave this one over here. So let's get back to grid base. We call this function first, which is create cover positions. That basically comes over here. It takes the list, so it takes the list from the node reference, and it initializes as everything as none, but it also adds them into a new list. So it creates a new cover position, and it adds them to the list of the node that is on the node reference. Okay, and then it goes and assigns it like the way it should be. So the first entry will be the north direction, the second the south, the third will be the west, and the last one will be the east direction. So basically it takes an empty list, creates a new cover position, assigns it to that list, because when you create a cover position it's not already in the list. Okay, so when you have all your list, you can go into directly independently into each one of the entries and set the direction to the one that it should have been. Okay, so this creates the cover position and basically populates the list of covers. And since we know the directions will always be the same, we can simply hard code it like this. So we saw how to create the grid. Now we need to actually read the level, and we also need to add this after creating the grid. Okay, so to read the level we still need these three for loops for each of these cases, but we do not need to. We know what node to get. Okay, we already have the grid. We're not creating the grid. We're just looking if any node we have has anything else in it. Okay, we know the offset, so we do not have to calculate again. We can just take it from the node reference transform position x, y, and z. Similarly as before, we do a box cast all with these values, and for each hit the box cast all has, we can come over here and say if it hit something that has a level object collider, we store the reference and then we start checking if that level object, if the level manager level object y object does not contain the game object we just hit, then add it. Okay, this stays as before. We change the tile renderer, and then here's where we actually do the changes. If we hit an obstacle, then the node is not anymore walkable. This will change in the future. Change tile material to red, and here's where we actually do a few changes on the level object. So let's pick the definition for the level object. This is the class for the level object, which created in the previous video, and the only things we added was we can now have an obstacle type. So we hit an obstacle, but what type was that obstacle? And it can be either a full or partial obstacle. A full obstacle will give full cover. A partial obstacle will give partial cover. Okay, simple enough. But the thing is now that because this is an obstacle and this is unwalkable right now, okay, then that means the player will never be able to be over that node. So we need to change all the neighboring nodes. We start with a target status so that we can apply it over here. So we're not doing a bit of encapsulation, we are basically doing over here. Okay, later on when we have more updated, when we are going to update the pathfinder and all that stuff, we will actually only make it unwalkable when it's a full cover obstacle. Or you can make it, not make it just unwalkable, you can make it climb that obstacle, but this is, I'm going ahead for myself, so let's move on. Okay, we find the target status for what type of cover that those nodes will have. So we can come over here and say if you find a next obstacle on your node, basically not just your north and east, update every node, every neighboring node you have on the north, on the east, on the south and the west. How we find this? We can use get node, and we can keep adding to the z, to the x, minus z, and to minus x. And we change the directions for the north node, node reference. The cover status for the south direction will be the target status we have over here. So for the east, for the east node, it will be it will change, we will use the direction of V. Okay, the south, the north direction will use, and I think this is, I have it the opposite way because there was somewhere an error that I couldn't find, but it works. If it doesn't work, just change this to west or east and we will see what will happen if it doesn't work. Okay, so we will basically go into the neighboring nodes, and from the direction they listen to the node we are right now, we change the cover status. So let it load. Okay, basically this node has partial cover, so that means this node from the north direction, from the other side, okay, even if it's to the south of this node, that means the north side of this node is actually what gives the cover. Okay, later on we are going to add the partial cover to the actual node in it, exactly like how XCOM does it, or the newer XCOMs. Okay, and we do a break for this object. If the same as before, if it was a level object of floor, then that means it's walkable and we change the tile material to none. So this is pretty much the bigger change we need to do over here. Okay, so with that in mind, we can come into our player interactions list, script, not list. Okay, and we can know when we can actually activate the combat indicator. We can keep it the same way when we have the visualized path, since if there is a path, there's probably you want to know if you are in cover or not. Okay, so we just go and enable the game object whenever we can actually visualize the path, and on the else statement of this if statement, on the else case, we simply disable the path. Now let's see the new references we have on the node references. Okay, we saw our list, and we also have a set cover status, and we also have return cover with direction and return first cover option. Set cover status and return cover with direction is the same as the one we have on our World UI Manager, but instead of, we basically have one more extra step, and I should have closed that. Okay, and yeah, it's not that, it's actually the cover indicator. Okay, it basically has one more extra step, this set cover status. So in our node references, oh yeah, I made a mistake. When we actually create the grid, either create or read the level, I think. When you want to update the node and the node references, you need to call the functions we have inside our node references. Okay, return cover with direction and set cover status. Grid base, let me find the path, get node, not from all, get node, where is it? Grid level. Okay, this is called, it's not from the World UI Manager, but from the node reference. Okay, it's not the same as the one we have on our World UI Manager. So the next function we have inside our node reference is a public cover that returns the first cover option we have. So when your character moves on a node, we return the first cover we can find. Now if the cover of the node, not the cover, has multiple cover positions, that is basically depends a lot on what you want to do there. Okay, so I think in XCOM it goes around where the enemy is actually located, but it not always work like that. So it needs a bit of thinking over here, but for right now, for the purpose of this video, it's pretty much enough. So what it does, starts with a return value of null, and it goes and finds, if it finds a cover status that is not none, okay, it will assign it as the return value and it will break the for loop, else it will return the return value. And we actually do want to know if we returned a return value to null later on, and we want to know that inside our unit controller. But before we see the unit controller, we're going to see into our node, to our unit states. And no, we do not want this one, actually, this one from the previous video. Let's see our unit controller or player interactions. Let me think for a bit. So we need to add, we have our units, we have a way to read the level, okay, and all that stuff. Now we need to assign the actual interaction, the player interaction, when we are upon a node, to actually read that we have, that node has a cover position. Okay, so let's go do that before we move to the units. And we do that by checking the move unit. So if you remember, we were doing everything over here. If we have a path, and if we have a node, okay, if the target node is not null, and if the target node didn't have an enemy and all that stuff, and basically we need to come over here. If the target node didn't have an enemy and it was inside our basic move and double move nodes, okay, before we request the path find, or we after request the path find, we say go to the world UI manager and update the list of cover with the list that the target node has. Okay, so basically see what that node has for cover positions and update the cover indicator with that, and we move the cover indicator's position to the node we are above. Okay, and that's basically what it does, how you read if your node has cover or not. Now only thing left is to see the unit controller, but before we see the unit controller, I've did a few changes into the animator. So if you remember, we only had locomotion and it was moving from idle to run, but we're going to change this, and this shouldn't be locomotion now. We are going to name this idle, and when we wanted it to run, it's going to transition to this state. We're going to keep the run over here. It's going to transition to this state whenever the movement is greater than 0.1, and whenever the movement is less than 0.1, then it's going to play the idle animations. We're going to add a new float for distance, a new float for direction, and a new boolean if we can shoot or not. And inside the idle, we have a blend tree that has one animation and two more other blend trees. Those two other blend trees, the animations, by the way, are the ones I'm using on the third-person shooter tutorial. Okay, I will probably have a link in the description. Okay, they are not really anything great, just something to work with. Now, as I said, the first blend tree is the one that has the crouch. Okay, cover crouch left. If its direction is -1, will be the animation we want it to play when he's crouching and he's looking to the left, and if the direction is 1, when he's crouching looking to the right. But the partial cover has also the middle direction, okay, because it's basically probably is a short wall, you can actually get up and shoot. So with that in mind, the next blend tree, which is the full cover, does not have a middle direction, it will either be -1 or 1. Okay, because if it's full cover, and even if the enemy is directly in front of him or somewhere over here, then that means there's a wall between them, so he cannot just shoot on the wall. Okay, now sometimes or not sometimes, XComp might allow this if the next node next to the player is actually empty, and we're going to see all that on a later part. Okay, for right now we're only going to focus on making the basic system. So for this case the idles can have, we can, similarly to the previous the way we did it before, we can transition to the aiming we actually want to use. So the previous aiming was, if he was aiming it was true, it will move to this state behavior, to this animation layer, to the aiming. Okay, now we're going to add, if the stance is also less than 0.1, so that means if the character is crouching or he's in cover, then that means it's going to skip this part, this state, and it will move to this one. Now inside it I've kept the same stuff. Okay, this transition doesn't matter, since to come inside the state is going to be true. Walk sideways, and basically it's the animation it plays and then it actually starts aiming. Now on aim I've created a new script, an animator state behavior, that basically changes a bool. We pass a bool name, the status, and if you want it to be reversed on exit. So when it enters the state, it's going to find that bool and it's going to make it the status you have over here. You basically probably want it to be true. Okay, so if you want it a boolean to, or you might want a boolean to close. So yeah, anyway, if you want it to reverse on exit, when it exits the state, it's going to go to that the state, to the bool name you give, and it will give it the opposite you pass on the status. Let's close this. Let's go back. Okay, so this is the aiming we had on the previous videos too. So on the aiming crouch, we're going to actually see if we are aiming, if the stance is greater than 0.1 but less than 1.1, because on 2 it's actually the full cover. Okay, so when it comes in here, you'll see that we actually have more animation states over here. And I forgot to say what this does. The aiming, on the aim, we need to add the change bool, the can shoot, to true. So when the aiming is over here, we go and turn this true, and we reflect with this boolean, and if it's true, we actually fire the particles and all that, and continue our shooting behavior. So in here we have we have cases for each way we can come and shoot. Okay, so cover crouch left to aim. What will make him do is play the animation where he gets out of cover and he starts aiming. When he's aiming, we have the script that says you can shoot, so it can shoot, and when the aim is false, he will return back to cover, and then with exit time continue on. If he's aiming directly from getting up, okay, then he basically, whenever he's in this state, he can actually shoot, and when he's not aiming anymore, he can go back to being crouched. This one is not crouched, but because it reflects back to the blend tree. Okay, but when you are in game, it will be crouched. The other way will be when we're crouching from the right. Okay, when we are aiming, we have the change bool that we can actually shoot, and when you are not aiming anymore, when aiming is false, we will play the animation, and this in turn will return back to the idle. The same over here for the aiming. When you are not aiming anymore, exit this state behavior. And aim full cover, exactly the same as the crouch, but plays different animations. And when you are aiming, you can actually shoot. Okay. So this is the changes we did on the animator, and now we can go back and we can actually see the changes we have to do on our unit controller, and there are quite a few. We're going to use two new booleans where we had the fire once, but we're going to change all the logic behind it. Okay, init for combat. So where we have on update, if we are moving the path and we have reached the path, where basically we had the path, we were moving our character, and we're not moving anymore, but we said that we were holding a path. Okay, then we can actually check the node if it has a cover. So we basically say, when you stop to a node, check if that node has a cover. The way we have set this up works pretty much without having to change anything. Let's see the check node for cover, and it's this one, check node for cover. We have a cover sem, and we use the current node we are upon, because we find the current node, if you remember, from the store reference on node, and I think was the store reference node. Yeah, it's the store reference node. So we know the current node is the node we are upon. We can find the node references, and we return the first cover option. If the cover option returns null, well, that means there is no cover position, so the animator should play the stance, should play the idle when he's just standing up. But if there is a cover position, we set up the direction by default by 1, but as I said before, you should probably tweak this to be what you want to use. If the status is partial, then we change the stance to the crouching animations. If it's full, we change it to the ones when we are in full cover. We have a switch over here, and we say check the direction, and based on the direction we have, start the coroutine, which rotates the character to face the direction. Since we use world directions, okay, north, south, west, east is world directions, we can pass it straight up the vector 3 forward, or the opposite of the vector 3 forward, and then vector 3 right and minus right. The coroutine to rotate face direction, it's this one, but as you can see, it takes a target direction, but it also takes a boolean aim at the end, which initializes as false. Okay, and that's why you do not have to pass another value. You can call this coroutine without having to pass the status for this boolean, because it's already initialized. So rotate to face direction, we normalize the target direction, even though I think there's no need, since the target direction, the way we use it right now, there's no need. But if you call it elsewhere without using the vector 3 shortcuts, then you should have it normalized. This takes care of that. Okay, so if the target direction is vector 3.0, then it assigns it to be the transfer.forward. the starting rotation will be the one the transform have, and the target rotation will be quaternion.look rotation to the target direction. We initialize the float t, and while t is lower than 1, we keep adding to the t, and on our rotation we do a spherical interpolation from the starting rotation to the target rotation, and we pass the t. We yield return null until the while is complete, and when it's complete, if we passed the aim at the end to be true, then we go on to our animator and say set the boolean of aim to true, and we will see where we use this. So check node for cover, and we call this whenever we reach the node. And we probably, if we call this on start, it will probably make them play the animations when we hit play, and it doesn't. So it gets a null. Oh, it gets a null because we haven't yet initialized the animator. But what we can actually do, yeah, we're going to see it on a later video. We can on a later video we can basically set every start to be a public void, and not call it start, of course, something else, and call everything from the unit stage. So we have an order of calling it, but anyway, it doesn't pretty much matter over here. So where we are, we know we change the animations based on if the nodes have a cover position. What's left to do is when we're actually shooting, so that is when we handle the combat animation, is to take care and make the logic before we actually shoot, what animation to play and what to do there. So to do that, similarly as before, if the state says we want to shoot, here's where we change everything. So if we haven't initialized yet for combat, we check the node for cover once again. Okay, and we say we need to find the direction between the enemy that we're going to attack and our own position, and we need to find now the dot product between our own forward and the direction of the enemy. If the dot product is lower than 0, that means he is behind us. So we change our stance with a new variable, a new coroutine we're going to create, which is this one. Okay, this does what it says. It lerps an animator float value. So we pass the target float, the target we want our float to be, the actual name of the float, and it also takes a boolean if we want to aim at the end. So it comes over here, it gets the float with the name we are passing from the animator, it assigns the target we want this float to be, initialize the t, and while t is lower than 1, it starts adding to the t, and it sets the float with the name we are passing. It basically lerps from the current to the target based on t. Here return null until this is complete, and if you do not add a yield return to a coroutine, you're going to crash Unity, just keep that in mind. So if we pass that we want to aim at the end, then we set the animator to say aim. So basically what this does, it just lets the character rotate to face the target, changes the stance, and when either the rotation or the stance is the one that we actually want to use, then it turns the aim boolean to true. So if the enemy is behind us, we change our stance. We basically we do not want to be in cover anymore, and we are not basically in cover because the enemy is behind us, so the cover is is in front of us. Okay, we change our cover, our stance, and then we go and change our direction to face the direction we want to have. So we start the coroutine, rotate to face direction, we pass the direction, which in our case is the direction the enemy is, and we also want to aim when the rotation is complete. Okay, this is a fast way and a simple way to basically make your character aim when he's actually facing the enemy, and not rotate, not aim when he's not even looking at the enemy. Okay, so if he's in front of us, we need to find the angle between the direction of the enemy and our own forward. If the angle is lower than 5, then we change our direction from to 0. So that means it will come over here if this loads. It will come over here and change the direction to 0, It will move to this, and to actually, I forgot to mention this, to actually transit to the state, crouch, to decide which of the states to play, you need to assign transitions over here. So if the direction is greater than 0.1, that means it's going to be 1. It's going to play the animation that gives out of cover from the right side, from the middle side, basically just standing up. Okay, this one is the tricky one. It needs to be greater than minus 0.1, and it also needs to be less than 0.1 the direction. And for the left, you want the animator state less than minus 0.1. Okay, and the same for the other direction. Since we only have two directions when we are in full cover, if it's less than 0, that means it's to the left. If it's higher than 0, that means it's to the right. So we lerp our direction. Instead of we basically reuse the lerp anim float. Okay, instead of doing it for the stance, we use the direction. And we also want to aim when he's finishing changing the direction. If it's greater than 5 degrees, the angle, but it's also lower than 60 degrees, we also need to find the dot from the right. We find it with our transform dot right when we also pass the direction, and we say start the coroutine to lerp the anim float. Okay, we still need to change the direction, but if the dot is lower than 0, that means we want the direction to be minus 1, else we want it to be 1. We pass the name, which is the direction, and we also want to aim when this coroutine ends. Okay, this is simple, even though it might not look like that. This is pretty simple. If it's greater than 60 degrees, then that means she's probably behind us, so that cover, we do not really have any cover. Okay, so basically do the same as you did if the character is actually behind you. And that pretty much makes this redundant, to be honest. So even if I delete this will still work. But let's keep it, doesn't matter. So we updated all the values we have on our animator. We started coroutines to actually start aiming when we are looking at either the correct direction or we are playing the correct animation. So we can say init for combat is true. Okay. So the only thing left is to actually check when the animator tells us that we can actually shoot. And we do that by using getBool_canShoot. And when this is true, if we haven't yet fired, because the canShoot can be true for more than one frame. Okay, if we haven't actually fired, then we can actually call the previous coroutine we were using, which is playParticle. We can pass a delay so that we do not shoot right away, and we say fire once. And on playParticle, we do the same as before. Okay, the delays, and we can say over here we can start resetting our values. Okay, we're not shooting anymore. We haven't yet initialized for combat, because any new combat will be a new combat. We're not aiming anymore, and we also haven't fired. So next time it's going to loop and play exactly as it should. Let's see if I have anything else. I have not. Okay, there's no need for this. And I think this also no need. So that's basically it for this part. Let's actually see it. Let's clear this. Let's see the camera now, but it's not something unique. As always, we have an empty game object and the camera inside with offsetted from the center. Okay, so we move the camera holder around and our camera sits over there. We can create a new script called camera handler. Camera mover is this transform, camera speed, and a boolean if the camera is rotating. On fixed update, we can call this function handle camera movement, which takes the horizontal and the vertical. It creates a new vector 3 for right and forward. It takes the right transform, the right direction from our own camera. It multiplies it by the horizontal and by the camera speed. Same for the forward, but for the forward. But for the forward, because the camera is looking down, we want to change the Y to 0. Otherwise, we will be, when we are pressing W, we're going to be going through the ground. We create a new position. We basically add right and forward, these two vectors, and we change the camera movement position with we basically add the new position. Now, if the player hits Q, and if we are not already rotating, get the Euler angles we have from the transform and add to the Y, add 90 to the Y, and we have a new coroutine, rotate around self. It basically makes a simple rotation. We pass target rotation and it rotates. Okay, it's the third time we see this today. Starts the coroutine and says rotating is true. If you press E, the same, but the other way around. And when the coroutine ends, it's going to make the rotating to false. And that's how you move the camera. Basically what it does is I move the camera around, and when I press Q or E, it rotates like that. So I can take my characters now, I can move them to cover positions, I can shoot from cover if I have action points, of course. Okay, you see, he gets out of cover, he fires and gets back. He goes into a full cover position, even though it's in the center. The collider reaches over here. We're going to fix all that on a later video. If I hit, he's going to get out of cover and he's going to shoot. We're going to end the turn, and the same for the other guys. Okay, going to shoot, and if the target is almost directly in front of him, yeah, this didn't work, it's more than 5%. But if he's directly in front of him, he's going to get up and shoot. So I'll end this video over here. Next time we're going to see a lot more advanced stuff. This was mostly simple, but it's still a lot of stuff to do and add. So if you like it, you know what to do. Get involved, click like, subscribe, share it with your friends or families or associates or whatever. If you like to keep making these videos, you can then consider supporting me either on Patreon or grabbing a project or two from Gumroad, so we can continue keep making quality content. So I'll see you next time.